All right, good afternoon. Happy Wednesday. Finally said afternoon instead of morning. Catching on here. Slowly but surely. I finished lesson 3.1 the other day, and we actually in Teams worked on the review test for 3.1. Lesson 3.1 is due tomorrow night, and the review for 3.1 is due Friday night, and then we're going to have an exam on 3.1 on Tuesday morning. So just a reminder, you can't miss the exam. There's been a lot of people making up various excuses, but I can see the exam. I know that I did it. So if only one person out of 70 is having problems and something's fishy, you cannot miss an exam, or I'm going to request a parent conference. So just make sure that you're taking an exam unless you previously talked to me about not taking it for some reason. Also, I wanted to commend you about your work yesterday in the Math Wizard teams. Things are a lot better. You guys are collaborating a lot better. I noticed that you're asking more questions, like what problem should we do? You know, what's the first step? Should we divide both sides by 2? What should, and it's working out a lot better. So I guess the thing is, if I don't have a lot to say to you in the groups, it means that you're doing what I want. And it means I don't want to interrupt you. So good job on that group. We're getting better and better, and we are working problems more efficiently as a team. One thing I noticed yesterday was one person wanted to do the problem one way, and the other person wanted to do the problem another way. And what you have to do is try to convince each other what way is most efficient and the best way. And then your group has to do it that way. So you cannot do it your way and that your classmate do it another way. You have to agree on what the most efficient way is and try to convince each other of what to do. But good job with the Math Wizard teams. You guys did really good. Okay, so the first thing we're going to do today is I'm going to take questions on lesson 3.1. I do not want to work a lot of problems right now. You are responsible for working problems. You can go into those Math Wizard teams at 9 o'clock at night if you want to work problems with somebody. So those Math Wizard teams are open all the time. So all you have to do is get some classmates together and work on it. I do expect you to ask questions of your classmates before asking me. Now, that does not mean you can't ask me questions. I can answer questions anytime you want. It's just that I don't like to field a bunch of questions after I've already taught it. I just feel like you need to be responsible for talking to your classmates first, then come to me. Okay? All right. So anybody want to ask me about any of the problems in 3.1? So nobody has any questions or problems whatsoever in 3.1. That's hard to believe. So there's no questions about the word problems. There were 3 different types of word problems that we looked at. Nobody has any questions about anything. Okay. All right. Well, 3.2, you're going to like, because it's going to be one of the easier sections. So do you guys have a question? All right, we're looking at the complex numbers, and I've already talked about them a little bit. So this is the California Common Core Standard N-CN.2. And one of the first things that they do is they give you a polynomial expression. And they have you do that. So this would just be 3 plus 4x plus 2 minus x. So you just combine the terms. 3 plus 2 is 5. 4 minus 1x is 3x, and that's your answer. And so they turn around and say, what if you put an I in for x? So instead of 3x plus 4x, you have 3 plus 4i, which is a complex number, plus 2 minus I. Well, the point they're trying to get across is that you treat I, even though it's a number, you treat it like it's a variable. So you just do the same thing. You just say 3 plus 2 is 5, or you can rewrite it. 3 plus 4i plus 2 minus I, combine like terms. 5 plus 3i. So they're just showing, they want you to know that you're treating I like it's a variable. That's the first thing. The second thing is what I've already taught, and that's about complex numbers, and what's under those are the real numbers and the imaginary numbers. So let me look at the question in your book. So the question in your book says, identify real and imaginary parts and then it says, state the set it belongs. In particular, complex numbers, real numbers, or imaginary numbers. And they're talking about pure imaginary numbers. So two things you're doing. So given this problem, -6 plus 2i, they want to know what the real part is. So what's the real part?
-6.
What's the imaginary part?
2i.
Just 2. I is the imaginary unit. 2 is the imaginary part. I is the imaginary unit. Okay, so that's done. Now it says state the set. Is this complex, real, or imaginary?
Complex.
That's correct. So let's say you have -7.
Oh my goodness.
You guys okay? You guys okay? Are you there?
Yeah.
Okay. Can you guys see me and hear me okay?
Yeah.
Okay.
Yeah.
Okay. So what's the real part here?
-7.
What's the imaginary part?
Isn't it 0 or 1? I forgot.
0.
Okay.
Because the form is -7 plus 0i. There is no imaginary part. Right? Remember the complex number is a plus bi?
Can you move your screen down a little bit?
So what kind of number is this? This is complex, real. So it's complex, real. So what's the real part here?
0.
Right, because the form is 0 minus 3i, right? And the imaginary part would be what?
-3.
-3, right? And so what is this thing? Well, this thing is complex, pure imaginary, and they're just calling it imaginary. All right. So they want you to state the real and imaginary parts, and then you're stating what set it belongs. So remember that all the numbers are complex. All the numbers are complex. They're either just complex, complex real, or complex pure imaginary, but they were just writing imaginary. Okay, now this next part is going to seem like I've already taught it, but I haven't. And it's adding, subtracting, and multiplying. So this is very similar to when we added and subtracted polynomials. So here we go. So you're going to have a complex number like -2 plus 5i, and we're going to add it to another complex number, -6 minus 3i. Well, you can drop off the parentheses, -2 plus 5i. That would be -6 minus 3i, and you just combine like terms. So a negative and a negative is a negative, and you add, and 5 minus 3 is 2i. And make sure that you put it in standard form of a complex number. Can you divide by 2? Can you divide by 2?
Yeah.
Is this an equation or an expression?
Expression.
So with an expression, you can divide by 2 without destroying the problem, or can you only divide by 2 and you can balance both sides of an equation or balance up and down?
You have to balance both sides of the equation.
Right. So I'm going to ask you again, can you divide by 2 and with an expression?
No.
No, you cannot. Let's try another problem. This is an addition problem. So you're adding 2 complex numbers. So this should just be 3 minus 7i. You can drop off the parentheses, minus 5 plus 9i, and combine like terms. So 3 minus 5 depends, and opposites subtract. Negative and a positive depends, positive, and opposites subtract. Can I divide by 2?
No.
No.
Absolutely not. So let's go to subtracting. Got to be careful, right? Because don't you have to distribute -1 to both of those? So wouldn't this be 8 plus 2i? What?
Six plus 4i.
Minus 6 or plus 6?
Wouldn't it be
Plus six.
plus because it goes into positive?
A negative times a negative is a positive. And then what's this?
Positive 4.
Positive 4i. A lot of people are just going to bring the negative down and get it wrong. Don't be one of those people. So a negative times a negative is a positive, and a negative 1 times a negative is a positive. So now you combine like terms 8 and 6 is 14, and 2 and 4 is 6, and you're putting it in standard form of a complex number. So once again, we're subtracting two complex numbers. So I would distribute the negative 1. So what do you get when you distribute a negative 1?
Negative 4 minus 2i.
That's right. So now a negative and a negative is a negative and you add, and a negative and a negative is a negative and you add. So you guys okay with that?
Yeah.
So now we're gonna multiply two complex numbers, 8 minus I times negative 7 plus 4i, and notice that there's no plus or minus. So some people are gonna add, but if there's no plus or minus, this is a multiplication problem, and you have to FOIL. So when you FOIL, you get negative 56, outer would be 32i, inner would be positive 7i, and the last would be negative 4i squared. Now, isn't I squared equal to negative 1?
Yes.
So wouldn't this be negative 56 plus 39i minus 4 times negative 1?
Yep.
So wouldn't that be negative 56 plus 39i plus 4? So wouldn't this be a negative 52 plus 39i? No comment? Hello?
No, I
All right. So what if we have negative 2 plus 4i times 5, say minus 6i. You have to FOIL, right? So would that be negative 10 plus 12i plus 20i minus 24i squared? So wouldn't that be negative 10 plus 32i minus 24 times negative 1? And wouldn't that be negative 10 plus 32i plus 24? So wouldn't that be 14 plus 32i in standard form of a complex number?
Yep.
Okay, does anybody have any questions about adding, subtracting, or multiplying complex numbers? You can't expect this. If we do have a district benchmark, this will be on the district benchmark.
There you go.
Can you lower the board, please? Thank you.
Can I erase it?
I finished copying it down.
Okay, now I'm really excited, especially for those of you who want to be electrical engineers, because today I'm going to teach something I'm not supposed to be teaching, but I do want you to see an electric circuit, and I want you to see how the imaginaries come into play with the electric circuit, resistors, capacitors, and inductors. So we're going to look at the electric circuit. It looks like this in your assignment. So there's going to be 3 circuits, and you're going to have to find the voltage for these. And we're going to go through this right now. So please open up your book to page 131. An electric circuit has 3 types of components. Okay, it has a resistor, inductors, and capacitors. And if you see the box here, you see that the resistor looks like a zigzag. The inductor symbol looks like a coil, and the capacitor symbol looks like a set of parallel lines. So I'm going to write down the circuit up here so you can see it in this particular problem. So this zigzag is the resistor, and in this problem, it's 4 ohms. So that is an ohm. On the right is the coil, and that is 3 ohms, and that represents the inductor. And the parallel lines are the capacitor, and in this particular problem are 5 ohms. And over here is the voltage of the circuit, which is 120 volts. Now, read with me in the very middle of the page. A diagram of an alternating circuit alternating current electric circuit is shown along with the impedance measured in ohms. Now, the impedance is the opposition to the electron flow. So the impedance, which is shown on the left in the diagram and labeled 120 volt, causes electrons to flow through the circuit. Let me start over. A diagram of an alternating current AC electric circuit is shown along with the impedance measured in ohms of each component in the circuit. An AC power source, which is shown on the left in the diagram and labeled 120 volts, causes electrons to flow through the circuit. Impedance is a measure of each component's opposition to electron flow. All right, so for this example, the first thing we're going to do is find the total impedance. Now remember that that right there is this is going to be opposition to the flow, and we're going to find the total by adding up the components. So the resistor is always a real number. The one that's a coil, which is the inductor, is an imaginary number that's positive. And the capacitor is a negative imaginary number. And the impedance, by the way, is Z. So if you see what I did, they just gave regular numbers. I made the 4 positive, I made the 3 positive imaginary, and I made the 5 a negative imaginary, the way they're defined. So when I add this up, I get 4 minus 2I. So that right there is the total impedance. Now, there's a law called Ohm's law for AC electric circuits. And Ohm's law says this, that the voltage is equal to the current times the impedance. So we're going to use Ohm's law to find each voltage for, well, the voltage for each component. But one more thing. In each problem, they will give you the current. So in this particular problem, the current is 24 plus 12I amps. That's just given in the problem. So let's just review what we have so far. We have an AC electric circuit. We have a total impedance of the components being 4 minus 2I. We're going to use Ohm's law to find the voltage of each of the components. And we're given in the problem the current being 24 plus 12I amps. So let's look at the voltage of the resistor. So the voltage is equal to, and let me just mark this. This I is the current. And this Z, of course, is the impedance. So over here, if I is the current, we can say I is equal to this. And that's given. So I, in this problem, is 24 plus 12I amps, and we're going to multiply to the impedance of the resistor only, which is a positive 4, and we get 96 plus 48I. That's the voltage of the resistor. Let's look at the voltage of the inductor. We're going to use Ohm's law. And that says that the current, which is 24 plus 12I in the problem, and we're going to multiply to the inductor's impedance, which is a positive 3I. Because remember, it's a positive imaginary. So this would be, what is that, 12? 72? 72I plus 36I squared. So this would be 72I plus 36 times negative 1. And to put it in standard form of a complex number, we would write negative 36 plus 72. So that's the voltage of the inductor. So last but not least, let's look at the voltage of the conductor. or capacitor, I'm sorry. We're not talking about trains. Capacitor, sorry. So we're going to use Ohm's law again. And we get the voltage is equal to I, which is given, 24 plus 12I, that's the current, times the impedance of the capacitor, which is a negative imaginary, negative 5I. And we distribute. So that would be negative 120I minus 60I squared, which would be negative 120I minus 60 times negative 1, which in standard form would be 60 minus 120I. Okay, so now, how can we check that we did this right? Here's what we're going to do. The voltage in this circuit is 120 volts. And the sum of those should add up to 120. So we're going to take 96 plus 48I. And we're going to add it to negative 36 plus 72I. And we're going to add that to 60 minus 120I. And hopefully we get 120. So this is a proof. So this 120 just floats along. So here we go. So 96 plus 60 is what, 156? I'm just going to put the negative 36 there. These two would be what? 120I? Minus 120I. Oh my gosh. So those are 0. And 156 minus 36 is 120. And look at that. So we absolutely know that we did those right. Because 120 equals the total voltage of all three components. So in this electric circuit problem that I gave you, they're going to give you a current in each electric circuit. You're going to find the total impedance. You're going to find the voltage of the resistor, the inductor, and the capacitor. And you're going to check to make sure you got the problem right by verifying that 120 volts equals the sum of the voltage. All right, does anybody want to ask me any questions about anything over in this area? Are you guys stunned? Are you guys okay?
I understand it.
Yeah. It's not difficult. It's just a lot of work. It's not difficult though. But I did want you to see how the imaginary numbers, how they work with an electric circuit and the way the current flows. And having to consider the impedance. It's interesting. All right, so we have some time for some questions. If you guys have, that is the lesson. So. Do you guys want to go over anything? Are you guys there?
Yeah. I don't have any questions. I don't know about anybody else.
Okay, do you guys have any questions about review 3.1 or practice AB or anything else that I've given?
Majority of it.
Okay. Any questions? Well, either you're completely confused or you're completely clear. I hope it's that you're not, I hope you're clear on things. All right, well, class ends at 2:05, so I'm gonna let you go. I hope that you understood that lesson. I hope it was easy. You can figure it out. Let me turn off the recorder. Hope you guys have a good day. If you want to hang out and ask me questions, you can. But anyhow, have a good day.
Thanks, Bert.
All
Have
right,
a
bye.
good day.
Bye, guys. Have a